Okay, it may seem like cheating for now, but I just want to remind you what we had figured out about this integral in the first video. We had figured out that when you take the derivative of e to the 2x plus 1, you get 2e to the 2x plus 1. And that this thing, the reason you had that 2 out there is this was an inner function, right? And so this integral does end up being equal to this over here, e to the 2x plus 1. But how would we figure that out if we didn't do what we had done in the first video? Well, the thing you're going to need to identify is that inner function, right? And so you can actually start, you'll be able to start seeing it without knowing the answer. The inner function here, like if you had to take the derivative of this, there would be an inner function, right? It would be this top thing up there. And we'll just identify that, and we'll call that u, 2x plus 1. And then we'll find the derivative of u, right? So u prime is equal to 2. The derivative of 2x plus 1 is equal to 2. And rather than write u prime, I'm going to write du over dx. Now I have two facts here. I have the fact that du over dx equals 2, and the fact that u is equal to 2x plus 1. And I'm going to substitute those into my integral. So I have the integral of 2e to the 2x plus 1 dx. And there I am going to put a u. And there, I'm going to put, sorry, I wanted to simplify this a little bit further. Remember, you need to solve this for x. And so this, when I solve it for x, I will get dx equals du over 2. And the reason I solve that for dx is now I can just drop it in right there. Right, drop in the du over 2, and I'll drop in the u there. And that's all times 2. And now I want to simplify this, so I'll have the integral of 2 over 2 e to the u du, which is just equal to the integral of e to the u du. And so the whole reason I'm doing this is I start out with this integral that I don't have the formula to solve. But now I have an integral that I have the exact formula for, right? The integral of e to the u, the integral of e to the u du is just e to the u plus c. That's one of the formulas we learned in 7.1. Now that I have gone through my integral, now that I've done my integral, I just come back to 1 and say, all right, my answer is e to the u plus c. Well, I'm going to substitute in what I knew u was from 1, that u is equal to 2x plus 1. So I'm going to have my answer is e to the 2x plus 1 plus c, right? And that'll be my final answer. The last simple example that we visited was something that came from an ln, right? We figured out that when we took the derivative of the ln of 2x plus 1, we got 1 over 2x plus 1, but then times the derivative of my inner function, that 2x plus 1, times the 2. And so we'll see that the key to this whole thing is identifying what that inner function would be. And so this looks a little bit different. It might be a little bit trickier to see, but you'll kind of start to recognize when I have fractions like this, that thing on the bottom, sometimes it's an inner function, right? And so I'll have u is equal to 2x plus 1. So kind of look at the overall arc of the story we're creating. We start with this integral that we do not have a formula for. I set u equal to 2x plus 1. I'm going to get the derivative of this. I'll write that du over dx is equal to 2, and I'll solve for dx. So dx is equal to du over 2. And now I have two facts that I'm going to substitute into this integral that was too complicated to do. Right? So I'll have the integral of 2 divided by u, right? Rather than 2x plus 1, I'm going to write u. And then rather than dx, I'm going to write times du over 2. Now this is going to simplify pretty nicely, right? This will be the integral of 1 over u du. So I started with this thing that I didn't know how to do, that I didn't have a formula for. Now I have the integral of 1 over u, which is something that I do have a formula for. If you look back at the 7.1 stuff, we know that the integral of 1 over u du is just equal to the ln of the absolute value of u plus c. Our final step is to get it back to the x's that we started with. I remembered from the beginning that u was equal to 2x plus 1. And so I'm going to take this, and I'm going to take that u, and then I'll write that my final answer is really equal to ln of 2x plus 1 plus c. Okay? So those are my simple examples, and the machinery is always going to work the same way. I'm going to start out by finding that inner function, which we'll talk about kind of some tricks to do that. But really, the way it's going to happen is you'll start to see lots of patterns. So you find the inner function, you take the derivative of it, and then solve for dx, and you plug those things back into the integral, and that gives you the integral that you can do. And then that's the one step where you actually do an integral. You're not doing an integral at any other steps. You do the integral right here. It's the only place in integral it's done. And then you substitute the x's back in to get your final answer.